If your chair structures ever look crooked, squished, or too much like a bow tie, don't worry. It's not because you're bad at art. It's because nobody's shown you the standard professional orientation for chair structures. This is the one that chemists actually use. Today, I'm giving you the last chair drawing method you'll ever need. It's the same geometry your professor, the textbook, chemical drawing software, and your exam will expect to see. Hey there, ninjas. All chair structure drawing methods are not created equal. There are several ways to sketch a cyclohexane chair, but only one of the orientations is the professional standard. This is the orientation organic chemists draw them in. This is the orientation that software like ChemDraw will draw chair structures. And it's almost certainly the orientation that will be shown on your exam. This is the orientation we're going for today. It's clean, it's consistent, and once you lock it in, every other chair structure problem gets easier. The entire premise of the chair structure is predicated on the fact that there are 3 sets of parallel lines in each chair structure. Within each chair structure, the orange lines are parallel to each other, the green lines are parallel to each other, and the red lines are parallel to each other, no matter which chair structure version you draw. To help us out, we're bringing back the ruled lines just like you learned how to print in elementary school. The entire chair structure is set in our first move. Start with the orange set of parallel lines. Angle them. Not too shallow, not too steep. Space them a good distance apart, not too close together. These are your rails. One chair structure angles up to the right, one chair structure angles up to the left. It may take a little practice to get these at the right angle so they're not too steep or not too shallow, not too close together and not too far apart. But getting these parallel lines right is the first key step to a good chair structure. Probably the biggest error I see in this first step is bringing the lines too close together. The second step will be drawing the green set of inner parallel lines. That's the signature move that separates a good chair structure from a bow tie. Once we have our original rails in place, we find our corner carbons. The corner carbons are our anchor point for every part of the chair structure that we draw. They are the furthest out points in your chair structure. For the chair that angles up to the right, the furthest out point would be the top right and bottom left. And for the chair that angles up to the left, the corner carbons would be the top left and the bottom right. For a good chair structure in step 2, we want to ignore the corner carbons and start from the inner carbons. This is the key step. If you accidentally start at your corner carbons for step number 2, that's when you get a chair that looks like a bow tie instead of like a regular chair. And here's the key move. Starting from the inner ends of your rail, draw a line that aims at the middle of the other rail but only goes a little more than halfway. Start at the inner edge of your rail. Draw a line that aims towards the middle of the other rail, but only goes a little more than halfway. This aim toward the middle is the geometric trick that makes your chair look like a chair and not like a scrunched zigzag. Then do the same thing with the other chair. Find the inner ends of your rail, draw a line that aims towards the middle but goes a little more than halfway, a line that aims towards the middle and a little more than halfway. If your chairs ever look distorted, this is usually the step that will fix it. Step 3 is the easiest. Once we have our rails in place, once we've drawn our lines that aim toward the middle but go a little more than halfway, the last step is to close the chair. Connect the dots, finish out the chair structure. Do the same thing for the left-facing chair structure. Got your rails, start at the inner, go a little more than halfway. Once you're at that step, the last step is to connect the dots, close the chair structure, finish the chair. If steps 1 and 2 were clean, this step is automatic. Now you have the foundational chair structure. This is the structure experts expect to see. Now, getting the distance, the angles, and the chair structures exactly right takes a little bit of practice. The good news? This is a very straightforward skill to practice. You could draw 100 chair structures before the end of the night. This is one of those skills where you don't practice until you get it right, you practice until you can't get it wrong. Practice until you can't get it wrong is a fantastic study strategy for organic chemistry. And I have a separate video that I'll link to down below that talks about that study skill. Once you get good at drawing chair structures, we can move on to placing the axial and equatorial groups. The most common exam mistakes come from misplacing the axial and equatorial groups around your cyclohexane chair. Let's start with the axial position. The first thing we want to do is identify those corner carbons, those signposts that are going to guide our way around the chair structure. The corner carbons are the ones that are furthest out from the center of the chair. For the chair that kind of points up to the right, the corner carbon is going to be the one up on the right, and the opposite corner will be the other corner of this chair. For the chair that points up to the left, the corner carbon will be up to the left and down to the right. Everything else we do in chair structure land depends on accurately finding the corner carbons, and finding the corner carbons easily comes from drawing a good expert chair. First step, we identify the corner carbons. One is up, one is down. For the up corner, the axial group points straight up. For the down corner, the axial group points straight down. Up corner, up axial. Down corner, down, axial. The axial groups alternate up and down all the way around the ring. For an up corner, we have an up axial. For this carbon that's kind of pointed down, we have a down axial. For this corner that's pointed up, we have an up axial. The down corner, down axial. Up carbon, up axial. Down carbon, down axial. And the same thing for our chair that points up. Up carbon, up axial. Down carbon, down axial. Up carbon, up axial. Down carbon, down axial. Up carbon, up axial. This up-down pattern never changes. Once you commit to this, you'll place axial and equatorial groups without even thinking about it. Drawing the equatorial groups can cause trouble for students because they'll try to draw the equatorial group perfectly horizontal or perfectly in the middle of the corner carbon. But these are incorrect geometries. In the standard method, they are slightly angled and always in the opposite hemisphere as their axial counterpart. Starting again with our corner carbon, if the corner carbon is up, the axial group is up, and the equatorial group angles slightly down into the southern hemisphere. If the corner carbon is down, the axial group is down, and the equatorial group angles slightly up into the northern hemisphere. And that's true no matter which chair you draw. Up corner gets a down equatorial, down corner gets a slightly up equatorial. The same will be true for the 4 central carbons. If the axial is down, the equatorial will be up. The question I always get is the equatorial up to the right or up to the left? Here's the expert viewpoint. For the central carbons, the equatorial group points toward the corner it is closer to. This carbon up here is closer to my carbon on the bottom left, so this equatorial group should point down towards that bottom left corner carbon. This carbon is closer to my corner on the right, so it needs to point in the opposite hemisphere towards the corner to the right. My last corner carbon is closer to my bottom carbon on the left, so I need to angle the equatorial group down towards that corner carbon on the left. And we do the same for the opposite chair structure. This central carbon is closer to the corner on the left, so the equatorial group needs to point towards that corner on the left. This central carbon is closer to the corner on the right, so its equatorial group needs to point toward the corner to the right. And we finish with our last 2 equatorial groups. If your equatorial groups look funny, you may have drawn it horizontal, you may have drawn it perfectly in the middle, or you may have drawn it towards the wrong side of the chair structure. Once you get good at drawing your chair structures, an amazing thing happens. You'll be astonished at how many sets of parallel lines are present in your chair structures. Certainly, all 6 of our axial bonds are parallel to each other. But watch this. We started with our first orange set of parallel lines. That touched 4 of the 6 carbons in the ring. Look at the equatorial bonds off of the other 2 carbons. These 4 orange lines are all parallel to each other in both of our chair structures. The green parallel lines touched 4 of our carbons. The green equatorial on the opposite 2 carbons make another set of 4 parallel lines. And the same with the red bonds. All 4 of these red bonds are all parallel to each other. If your chair structures aren't looking like the expert level yet, don't worry, that's not a sign of misunderstanding. It's a sign of an untrained motor skill that needs a few more reps. Practice is everything here, and when it starts to click and the parallel lines pop out, you are on your way to being an OChemNinja. From here on out, every problem involving axial and equatorial groups will feel more structured and less chaotic. If this helped, the next video will increase your confidence by showing you how to take one cyclohexane chair structure with substituents and convert it into its chair flip. We'll use this exact same chair structure shape to place axial and equatorial groups cleanly and analyze stability.
Thanks for training with us today, Ninjas. Check out this other content to see if you can level up even further. As always, don't forget to like and subscribe.